Alright, the last topic in that I want to cover in as far as nuclear goes, nuclear chemistry goes, is fission and fusion. How we a couple of reactions that are very important to us in terms of energy and things like that. Fission occurs when the nucleus of an atom has so many protons and neutrons it becomes so unstable that it splits into two smaller atoms. When this split occurs, when this nucleus splits and breaks into two different atoms, it releases a humongous amount of energy. We are interested in that energy that it releases. As a matter of fact, we typically harness that energy in a couple of different forms. Nuclear weapons and in nuclear energy. Okay? Nuclear weapons and nuclear energy. We use this energy in a nuclear reactor. A nuclear reactor is a device that controls the reaction in order to use the energy that's created. Typically we have control rods that provide shielding and decrease the amount of neutrons that are bumping into each other. But what we see in this is we have a neutron coming to a fissionable or a very unstable or very large nucleus. When that neutron comes and bumps into it, it breaks into two smaller nuclei with a humongous amount of energy release. Then we have two smaller nuclei that are probably still unstable, and you have neutrons that are coming off of it. These neutrons bump into more, so it's a chain reaction. It just gets larger and larger and larger, and we try to harness this energy. This energy, like I said, we can control with the nuclear reactor, shielding, trying to determine how many neutrons are bumping into these fissionable nuclei. Okay, the energy or the heat that's typically formed is used to turn a generator, a turbine generator, just used to, let me say this, used to heat water to the point that it becomes steam. This steam turns a turns a turbine. This turbine then in turn will produce electricity that we can see in our houses and throughout our schools in our daily lives. The other type of nuclear reaction that typically is quite important to us is fusion. And that's when we have two smaller atoms coming together to form a larger atom. This joining of atom also produces energy, but it requires a great deal of energy, or typically a high temperature. Where we see fusion most often is in the surface of the sun. Okay, we have hydrogen atoms coming together to form helium atoms. There's so much energy that is constantly being recreated and utilized that we have, for example, a deuterium or a hydrogen atom with one extra neutron, I'm sorry, coming together with tritium, which is a hydrogen atom with two neutrons, coming together. This is unstable. So an energy release is required, a neutron comes off, and a stable helium atom comes off. This is kind of the basis of Big Bang and a couple of other those stardust theories, if you will. But fusion is important to us in that it gives us warmth and the energy that we need from the sun. So this has just been kind of an overview of fission, where they come together, and fusion, when they go apart, the energy that's associated with them, and how we as humans can use this energy.